Let's start it.
Maybe that opens up the lobby.
There you go. Yeah, people are trickling in.
We can also stop the recording and then restart it.
That means there you go. And I'm going to go ahead and share my screen. All right, so panelists, can you see my screen? All right.
Yes.
Okay. So let me pull down some tools. Look at the participants. We have about over 24. So great. We have reached the criticalness. Good afternoon, everybody. Welcome to LSN Tech Talks. Today is November 1st. I hope you all had a great Halloween weekend and had a lot of candies. So today we welcome Bretty Perry and Richard Tavalici. My name is Ryan Thiha. I'm an assistant division manager at Wastewater Engineering Services Division at LA Sanitation. All right. Before we get into the main presentation, some housekeeping items. Forget about the first bullet. I don't think we'll be able to change our name to school abbreviation. So when you type in an answer in the Q&A, would you be kind enough to put your school affiliation if it's possible? That will be great. It will help us being able to keep track of your school attendance. So the questions will be answered at the end of the presentation. You can use the Q&A button at the bottom of your screen. And after the presentation, we will have a few slides that will go over the hiring information and upcoming events that LSN is hosting. Most importantly, this is a professional environment, so anyone exhibiting unprofessional behavior will be removed and reported to Zoom as well as your school. And this section is recorded and it will be shared with all the attendees that register through Eventbrite. So you will have full, complete information at the end of the presentation as well. With that, I'm really excited to introduce two speakers today, Brett and Richard. So I've known Brett since he started his career at the city. We used to be in the same division. We used to call it Watershed Protection Division, and now it's kind of split into two divisions, which is showing that we're growing quite a bit. Brett is an environmental engineering associate in what we call Safe Clean Water Implementation Division of the Sanitation Environment. He's working on a lot of high-profile projects such as the Byron Creek Total Maximum Daily Load project, where we envision to divert all the dry weather flow from one of the largest creek in the west of Mississippi. So as far as I know, it's one of the largest stormwater diversion projects. So he's taking the lead on that. Before that, he helped the LSN with the stormwater regulation, sample collection, overall stormwater program. And right now, he is a part of the program that managed the $300 million a year investment for the LA stormwater infrastructure. So thanks, Brett, for agreeing to be the presenter for today. Richard has quite a lot of experience. His background is in chemical chemist. He was a chemist when he started at the city, and then he finished his engineering curriculum at graduate level, and he became an engineer. So he has a lot of different perspective. He started out in the pollution assessment section, which is responsible for collecting water samples throughout the city from creeks and rivers and water bodies, and he's now doing the engineering work. So his work involves field monitoring, data analysis, data collection, and using the data to actually analyze and make conclusions and provide recommendations to build projects that ends up on Brett's desk. So it's really good combination. So at the end of the presentation, we'll go over the career opportunity. But with that, I'm going to hand it over to you, Brad and Richard, for your presentations. I'm going to stop the share, and it's yours now.
Thank you, Ryan. Let me share my screen. Can everyone see that in full screen?
Yes.
Yep.
Very good. Go ahead, Richard.
Thank you. Thank you, Brett. Thank you, Ryan, for that introduction. So good afternoon, everyone. My name is Richard Tavalici, here with Bretty Perry. We're going to be talking about how the city of Los Angeles protects its water bodies and watersheds from pollution. Just wanted to add one little thing about my introduction. As Ryan mentioned, I started my career as an environmental scientist, and with the help of the city's tuition reimbursement program, I was able to go back to school, receive an engineering master's degree. So if you work for LA San, it's just another great benefit to have that opportunity to return to school. And then Brett, do you want to talk a little bit about yourself?
Yeah, absolutely. Summarized it pretty well. Started off about 5 years ago in the Watershed Protection Division, and then when our division split, working on separate but still related work, now part of the Safe Clean Water Implementation team. So we'll get a little bit into what the scope of those two new divisions are, and that actually leads us into our first slide. We just wanted to help contextualize kind of where we are in the city, because it's a very, very large organization. The city is, of course, organized into different departments: water and power, airports, port, public works. So we're under the Department of Public Works, and there's a number of different bureaus. You've probably heard of Bureau of Engineering, Bureau of Sanitation, which is LA Sanitation Environment. There's also the Bureau of Street Services, or Streets LA. So under LA Sanitation Environment, we're here today focusing on the water quality and stormwater divisions, or program focus. So we're here representing the watershed protection and safe clean water divisions. And there are 24 other divisions that I'm sure you've been hearing about in the previous and to come tech talks as well. So I just wanted to situate where we are in the city.
All right, yeah, let's kick it off with watershed protection. Next slide, please. Great. So just to take a step back a little bit, since we're talking about watersheds a lot today, I just want to define what a watershed is, just so we're all on the same page. Essentially, it's a land area where all the water within a boundary flows into a final discharge or outflow point, as you see the pink dot on this map. It includes these three components listed here. And this map has actually more rural watershed, where you can actually pretty easily delineate the boundaries just by looking at the valleys and peaks of the topography. Next slide, please. So we live in a more urban environment, right? What about urban watersheds? Typically, these are more constructed or engineered conveyances, like look at a storm drain system, rather than those more natural channels in mountain regions. This is our first key term that's so very widely used in our field, the municipal separate storm sewer system. That's quite a mouthful, and it comes up all the time, so we shorten it to MS4. And the MS4 is essentially a system of conveyances that include all the components listed there to channel stormwater into its final destination. That could be a lake, a river, ocean, into the ground, or even potentially a treatment plant. Next slide. So I want to make this distinction between what the MS4 and what the sanitary sewer is. In newer cities, they've actually constructed separate conveyances for wastewater. Like that's what comes from your toilets and your sinks. And there's a separation between that and pure stormwater. And this is important because if you have a combined system and sewer and storm drain like in older cities, then it could potentially overwhelm downstream treatment plants when it rains and require discharge of that raw wastewater and stormwater mixture into a water body. So nowadays we separate these to prevent that from happening. A lot of our storm drain systems lead directly into the ocean, and that's why we need to carefully assess pollution in our MS4 and figure out what we can do to reduce it. Next slide. So I mentioned pollution in the MS4, but what kind of pollutants do we actually see in our watersheds? This is a pretty simple but good example of the typical pollutants. All of these accumulate on the street, sidewalks, and buildings over time and are transported through the watershed when it rains. So that dog icon denotes pet waste, and that could lead to bacteria issues in the watershed. The spray bottle would be some kind of pesticide or cleaning product that usually contains hazardous organic compounds. Cars, as I'm sure you're all aware, produce a lot of pollutants, such as combustion products that can be deposited onto roadways. Leaking oil is a problem. Zinc comes from tire wear, copper comes from brake pads. And lastly, trash is one of the first pollutants to be regulated closely, and that drove a lot of the water quality regulations for these other pollutants. Next slide. So now let's talk about the regulations, since they're very important. They govern everything we do here. Some of you may have heard of the Clean Water Act. This is a federal law that governs surface water quality all across the US. The Clean Water Act allows states to enforce regulations, and one of the tools they use to enforce is called the National Pollutant Discharge Elimination System Permit, or NPDES, another long acronym, comes up all the time. These permits are issued to anyone who wants to discharge water into a water body, and they always come with limits on the discharge amount and limits on pollutants. So the city is subject to one for its MS4 because the MS4 is within our jurisdiction. So we're responsible for meeting those water quality limits. My division's main focus is to comply with this permit, and it's quite a doozy. It's over 800 pages long. Unfortunately, it's not as fun to read as the latest George R. R. Martin novel, but so we have an electronic copy that we can search for the specific sections we need to reference. And we're currently working to implement new permit requirements that came out last year. Next slide. So just a little bit of the benefits or the functions of my division. Overall, our goal is to protect the beneficial uses of the receiving waters in the cities, lakes, rivers, and beaches. So we do this by improving water quality, capturing rainwater for other uses like for irrigation, non-potable, non-drinking water uses, recharging groundwater. Since a good amount of our drinking water comes from groundwater, it's important to keep our aquifers at a fairly constant volume. Reducing flooding is a big one, since protecting public safety and property is always your #1 priority as an engineer. Enhancing wildlife and providing open spaces for habitats is key. When we build our cities, we want to think green and reduce impermeable surfaces like roads, parking lots, and rooftops. A lot of our projects are also called multi-benefit, since they improve community aspects like designing new parks while also reducing pollutants in our watersheds. So using this approach, it could be a win-win for our community and for our regulatory requirements. Next slide. So I want to introduce the concept of a TMDL, or total maximum daily load, since this is a very common term as well. It goes hand in hand with protecting water quality. The simple definition would be this is a maximum amount of pollutant that is allowed to enter the receiving waters and not degrade existing water quality. So this table shows that we have 21 TMDLs in our region, and they're broken down by these specific pollutants. And the map on the right shows the 4 main watersheds that we oversee: Santa Monica Bay, Ballona Creek, Dominguez Channel. And the biggest one, a lot of you may have heard of it, is the Los Angeles River. Just to give you some context, we see downtown LA near the center, that red star, and that's very centralized in the watershed. It's almost like the heart of this whole region. Another notable landmark, the Santa Monica Pier, is on the west side more, and that's slightly north of the Ballona Creek exit. Next slide. So a core aspect of our work and my work also is the watershed management plans. These describe what projects and measures we need to do to meet our regulatory requirements. Typical stormwater projects are called BMPs, or best management practices. And you see in these figures, we have quite a few installed, however, in our watersheds. However, we do need to do a lot more installations to meet all of our water quality goals. So I'll show you some of these examples of BMPs in a bit. Since there's a lot of different cities in each watershed boundary, as you can imagine, we have these plans in place to coordinate efforts with other cities and agencies, since they're also on the hook to comply with the MS4 permit. We typically pool funding and resources from these other cities to work on these projects. For instance, one of my main roles is to lead a watershed management group for the Santa Monica Bay watershed. We're made up of several different cities and LA County as well, and we have a well-rounded team that we work together on compliance efforts. Next slide. So just a high-level breakdown of the strategies we use to comply with these regulations. It starts with coordination and integration, working with many different groups like other agencies, NGOs, which is non-governmental organizations, as well as community organizations. And this includes looking for different funding sources, planning projects in the initial stages. And when we actually build or implement projects, they're classified in different levels, starting with the smallest parcel level. And the biggest level would be the watershed level, which is designed to collect runoff from a much larger area for treatment. We work very closely with Brett's division in this process, Safe Clean Water implementation, to actually build and implement these projects. And then there's that multi-benefit aspect that I mentioned that is used to improve water quality supply as well as benefiting our communities. Next slide. So low impact development, just wanted to touch on this a bit since it's another good solid strategy that the city uses to improve stormwater quality and reduce runoff values post-development. So when a developer wants to build something new in the city, they need to create an LID plan that shows how they're managing the stormwater runoff on that new property. And our engineers will review that against the city's ordinances and MS4 permit requirements. So if you're the kind of engineer that enjoys checking plans, this would be a very good fit for you. Just some examples of the BMPs I've been alluding to: rain barrels starting on the upper left. These capture and reuse water for irrigation. flow-through planters. These are used to filter out some pollutants before runoff reaches the MS4. So the idea is to encase some of the pollution as it's flowing through. Dry wells can allow for storage and percolation of water into the ground. Permeable paving allows for some stormwater to also permeate or percolate through. This is typically used in alleyways and walking paths. Infiltration trenches and basins are a similar concept to the dry well, but they just require more land area typically. They're more shallow, but they're wider. So depending on how much land area you have, you can decide which is a better BMP for your development. Rain gardens, these also help with filtering pollutants and also improving aesthetic qualities of a property. And then last, we have the bioswale, which is also similar to a rain garden, a biofiltration system, but it's more linear feet, more channel-like. So it can actually wrap around a property and collect a lot of the runoff from that property. Typically, rain gardens, rain barrels, and planters are the most popular options for developers to use. Next slide, please. So just a little bit more about the sections in my division that support all the work that we do, starting with pollution assessment. This is the section I've mostly been involved with during my city tenure. Our objective is to monitor all the city's watersheds that I showed earlier. So we measure pollutant concentrations, flow rates, and other parameters in the MS4 to build robust data sets and check the health of our watersheds. So you see in that first picture, this is one of the channels in the Santa Monica Bay watershed, or sorry, the first upper left picture. You can see this is a large storm flow that goes into the ocean. So typically during at least 3 times a year, we go out and during rain events and collect stormwater samples because we have to quantify that. But below that, we see during dry weather, we actually enter the channels and measure flow and collect samples manually. Next, we have enforcement, and these are mostly comprised of inspection officers and law enforcement officers that investigate potential environmental crimes. So a lot of the times, if we see any illegal dumping of trash or other chemicals like paint, oil, et cetera, into the MS4, the first thing we would do is notify them, and then they would go pursue any potential investigation and do source tracking as well of some sort of pollution. Last but not least is our public education section, and their job is to teach residents about living more sustainably. Since everyone lives in a watershed, we're all responsible for doing our part in protecting them. Next slide, please. Okay, the last thing I wanted to touch on briefly, if our work interests you, feel free to visit our website, lastormh2o.org. It's an easy to remember URL. We released this website this year in partnership with 28 other cities and agencies to raise public awareness about our work. So if there you can find out more details about how we protect our watersheds, since this short presentation can't really cover everything, unfortunately. So that's all for my division and my type of work, and I'll now hand it off to Brett to discuss his division.
Thank you, Richard. That's an awesome insight into your division and a great foundation of all of these different core concepts in watershed protection. So as we've said many times, I'm from the Safe Clean Water Implementation Division. It's actually LA Sanitation Environment's latest and newest division. Every one of our staff, at least the continuing staff, came from watershed protection. So we have all of the DNA that Richard just went through and brought that into our new division to meet our new goals. So let's go ahead and dive in and see what this new program is. So I'm actually gonna tie back to what Richard was discussing. The Safe Clean Water Implementation Program and Division really are born from watershed protection, the MS4 permit, TMDLs, and the watershed management programs. So Richard has already discussed this, but we got our most recent MS4 permit in 2021. We are subject to 22 different TMDLs and our partner in 6 different watershed management programs groups. Just to show the scale of kind of what we need to build, if we were to build 100% of what is projected to be needed to meet all water quality mandates and goals, we would need to build out the capacity for just under 90,000 acre feet of stormwater capture. And that would cost, the estimate, and this is before the latest burst of inflation, would be $7.3 billion. So we don't have that on hand, but we do that as much work as we can, and we are constantly identifying new sources of funding. And a lot of our work goes into prioritizing what areas and what projects deliver the most benefits that we can with the resources available to us. So we do steer the Safe Clean Water implementation program in order to meet the various priorities that are identified by Richard and his team. And there also are numerous different nuances that we're trying to meet, but we can go ahead and now focus a little bit more on what is the Safe Clean Water program itself. So it was advertised as Measure W, and it was approved by a general election in LA County in late 2018. It actually needed 2/3 approval to pass, and it actually exceeded that with 69% yes votes. That was a great vote of confidence from the residents of LA County and emphasis that this should be a priority for the region. And it then took about 6 months, half a year, for the LA County Board of Supervisors to officially approve the ordinance and all of the language and details of how this program would be rolled out and administered. So our first tax collection was in the fiscal year 1920, and every single year throughout LA County, this program brings in about $300 million that goes to water quality and the additional water supply and community investment benefits that the program emphasizes. So with that $300 million a year, it is split into a few different buckets, just because that's such a vast amount of money. The county flood control district actually keeps 10%, and that helps them run all the administration, reporting, tax collection, all of the behind the scenes support efforts. And then in terms of the actual water quality benefits, 40% of the funds are returned throughout LA County to each individual city in which that tax was collected. So let's just say the city of Los Angeles contributed $1, we would get back 40 cents in a check. And that now has a numerous different requirements and reporting mechanisms that we have to meet, but that is now money that should be put into water quality improvement projects. The other remaining 50% is actually pooled within the watershed areas that Richard was discussing. There are slight discrepancies in the boundaries, but overall, there basically becomes a grant competitive process. So within Bionda Creek, all the funds between the different cities are pooled together, and anyone can apply for those funds. You do have to complete a feasibility study and meet some technical requirements, but it could be from any random person on the street all the way up to the biggest municipality applying for those competitive funds. So for the city of Los Angeles, it works out that we usually get about a $36 million check every year from the municipal return. And then we are able to compete with other people in the regional program for about $4 million in the Los Angeles River watershed and $17 million each in the Bionda Creek watershed and in the Dominguez Channel watershed. So first I want to dive into a little bit of what do we spend our municipal funds on. So as you can see here, the biggest section is that green section, which is our capital improvement projects. So this is the money that goes directly into the ground, implementing and constructing water quality projects. We then have another about third of our budget in the purple, yellow, and I guess red, orange, red, that is going towards supporting the staff of our division and actually the watershed protection division a little bit, and supporting the efforts that we have in the regional program. In order to apply for that grant opportunity, it involves a whole year of development, and we'll go into that a little bit, but it's essentially leveraging our municipal funds in order to excel better in our opportunities of getting water quality projects in the regional program. We then also do have in the aquamarine O&M budget, and that is to maintain the projects that we have built and make sure that they are staying functional. Most projects are designed with a 30-year useful life. Some of them have exceeded that, but O&M is an important program that is just getting lifted off the ground. So in terms of zooming in on that green capital improvement project, we don't have to go through every single line, but I just wanted to show you that we have about just over 10 or nearing 15 different projects that are currently being funded and implemented in the municipal program. So these are real projects that are going into the ground. We have 5 low flow diversions, which are finishing construction now actually, and then another series of projects that are all entering pre-design. And so these could range from low flow diversions, where we're diverting dirty urban runoff from a channel into our sewer. so that it can be treated appropriately at a reclamation plant farther downstream instead of entering the ocean. And then that ranges to more green projects, which could be green corridors, green streets, which are, think bioswales, street trees, and other efforts. If you think about some of the BMPs that Richard went over, the city actually implements many of the same technologies, just on a bigger and wider scope. So just to highlight, and I actually talked about it a little bit, but there were those 5 low flow diversion projects. They're supposed to be completing construction by the end of the year. The 5 of them together cost about $16 million. And the low flow diversion systems divert dry weather flow from prioritized, or the most polluted, stormwater outfalls to sanitary sewers for treatment at the Hyperion Water Reclamation Plant. So things that are constructed as part of this project include storm drain diversions and pipelines, trash collection structures, weirs, pump stations, valves, instrumentation so that we can control it virtually, numerous other technologies. Low flow diversions are mostly constructed below grade. So you can see in the picture in the top right, some of the infrastructure. So if you drive by, you might not know much is there, but it actually is a significant amount of infrastructure that's being installed to improve water quality. And so, of course, some of the benefits are improving water quality, meeting our regulatory water quality standards through the MS4 permit that Richard was discussing. And it also provides a new water supply. All that water that goes to many of our reclamation plants, by 2035, all of our reclamation plants should be at 100% water recycling. And so that is a new water supply that is extremely beneficial to the region, as I'm sure you've all heard of the mega drought and climate change moving forward. So shifting gears, that was a highlight of our municipal program. Now I'd like to discuss our regional program a little bit. So this is actually a program that's administered by LA County, and we're actually kind of considered as an applicant in order to pursue these grant type funds. And so we basically spend about a year. So looking at the timeline from the left side, it takes about a year for us to develop the feasibility study, which is essentially our application for funding. It would identify a project location, propose a certain scope, and then go through all the feasibility, what's already there, environmental permitting, and other considerations that are important before we go headlong into developing a project. It then goes through a series of different administrative and technical review steps that are led by the county. And you can see it takes all the way until the following July. Let's say you apply in July of 2020. You then would get an answer whether or not you would be funded in July of 2021. So then it takes another year or so to get the project delivery mechanisms in place, and then you can truly start design and construction. So these do have long timelines. But every project that is funded is vetted through a scoring review. And this is a panel of technical experts from various backgrounds, and they review that your project will meet the water quality, water supply, community investment, nature-based solutions, community support, and leveraged funding goals that the program is emphasizing. So these are, you can get up to 110 points, and you need to receive at least 60 to be considered viable. And the higher score you have, of course, that makes your project more competitive. So in the regional program, as I mentioned, the start date of the Safe Clean Water program, we've had 3 rounds so far. And so each of these columns represents investments that the city of Los Angeles, mainly LA Sanitation Environment, has successfully captured from the regional program. So orange would be the first year, fiscal year 2021, yellow is the second year, and blue is the third year. You can see there was a lot of excitement in the first year because there was a lot of funds slushing around. So a lot of projects were funded. And now it is more competitive as everything gets a little tightened. And as you all know, the current economic conditions. But I would highlight that in addition to our municipal program, our regional program has successfully captured over $200 million for stormwater capture project implementation, which is just absolutely massive, and why we need a whole nother division. That's why our division was created as an offshoot from the Watershed Protection Division. So there's too many projects to go through one by one, but I did call out a couple that will be in the following slides. But just to get a better idea of the whole package of what's been funded, each of these columns is an identified community benefit. And the number you see is the number of projects that have been funded and are currently being implemented by LA Sanitation Environment that delivers that project benefit. So let's just look in the bold region. We have 17 projects that will benefit disadvantaged communities, 18 that will reduce heat island effects, 17 will provide recreational opportunities, 19 will increases shade and trees. Throughout all the projects, there should be about 2,500 new trees being planted throughout the city. 19 other projects improve flood protection, 8 increase access to waterways and green spaces for, of course, our highly urbanized environment. 17 enhance habitat and park space, and 8 are directly adjacent to schools and deliver project benefits to schools. So below here, you can see a couple renderings for a few of our projects that have been funded that kind of illustrate the types of benefits and greening that will be delivered from these projects. And that's not even to mention the water quality benefits that each of these projects are designed to deliver. So we're killing two birds with one stone in meeting our water quality requirements and bringing water supply and community investment to the city of Los Angeles. I did want to highlight 2 of our projects that are funded in the regional program. First one would be the MacArthur Lake Rehabilitation Project. It's currently in the design phase and is scheduled to be completed in late 2025. It has a design capacity of approximately 4 million gallons per day that will be treated, and has a total cost of about 20 million. So you can see kind of an overview how closely this lake is located to downtown LA. And there's a brief schematic that shows the basic diversion from the stormwater structure and the pre-treatment facilities of the water, a couple of different bioswales, and water entering the lake. So some of the different components I just went through, and project benefits, of course, our regulatory water quality compliance, supporting public health and the environment watershed wide, and bringing community investment benefits. Many of the ones that we just went through on that previous table apply for MacArthur Lake. And a great thing about MacArthur Lake is it is implementing nature-based solutions, which is always a priority, implementing natural processes and materials to actually kind of mimic what was there before we built out the city. There was a natural watershed that had fewer pollutants and had natural processes to hold, slow down, and treat the water. And now we need to mimic that after we've built out such a impervious city and lots of concrete. Another project that's really important to highlight, this is leaning more towards the gray infrastructure. It's almost could be considered its own water reclamation plant in some ways. And this is the Bionda Creek TMDL project, or Total Maximum Daily Load project. This is an absolutely massive project that just started construction. It's also supposed to be completed in the middle of 2025. It has a design capacity of up to 29 million gallons per day and has a large construction cost of $76 million. So this is actually made up of 2 different regional facilities. You can see them on the right side, LFTF1, low flow treatment facility number 1, and LFTF number 2, and their locations are on the map. You can see the Santa Monica Bay. It's just barely that bottom left corner, and Bionda Creek flows towards the bay right next to Marina del Rey. So you're in the Santa Monica beaches and bay area. So this is a huge project that will really, really help us during dry weather. It'll help us meet our compliance goals for 330 days of the year because it's designed for dry weather. It'll also support public health and the environment watershed wide. There are Bionda Creek wetlands and a Bionda Creek estuary that all will receive purified water flows from this project. In addition, it is estimated to generate an additional 5,000 acre feet every year that will be diverted to Hyperion and used for water recycling. So that's an absolutely massive water supply that would otherwise just flow right into the ocean that the city is able to capture, treat, and recycle. I'm not going to spend too much time on this slide, but as hopefully you've seen in the regional program, it's on a cyclical basis. So every year we're implementing past year's projects, trying to get current year's projects funded. And all I wanted to do was give you perspective of the next round. So we actually just turned in our applications for round 4 in July of 2022. And these are the package of projects that we've identified for this round. I do want to highlight, as you all saw, the funding is, while it's still a massive amounts of funds, are becoming more limited as more and more projects have come on board. And so it's our job to identify as many grant opportunities and leveraged funding opportunities as possible. And we work with Richard and the watershed protection team to also identify some of those opportunities. But I just wanted to highlight that many of these project costs, like let's take the Hollenbeck Park Lake Rehabilitation Project, the first line, the total project cost is estimated to be about $44 million, but we've identified almost a 45% match that we can bring. So we're not laying all of that need and load on the Safe Clean Water program. So it increases the competitiveness of our projects. And that's something that we spend a lot of time in our planning group to become as competitive as possible to bring these benefits to LA City residents. So next steps, the Safe Clean Water implementation division is the newest division in LA San. So we are still working on setting up shop and ironing out project delivery processes, organizing staff, and setting up new administrative systems, because this is an unprecedented amount of funding coming towards watershed protection and water quality goals. As I mentioned at the beginning, there's billions of dollars of need, and the Safe Clean Water program allows us to actually start taking significant bites at that goal. So that's really exciting. And as we are building out this new program, we're also working on standardizing our resources so that all our projects are delivered in a consistent way, in a way that can be maintained and operated well by the Bureau, and that the community had extensive input and outreach for and take over ownership over the improvements in their area. So with that, I did want to go to our final slide. I would welcome anyone to take a quick screenshot of the screen, or I believe these recordings will be available at a later date. We're not going to spend the time to go through all these bullets, but these are precise language of position descriptions for both Richard's and my positions. This is invaluable for both preparation of any kind of interview or that kind of thing. And it also gives you a better idea of kind of, this is great, you're talking about all these different initiatives, but what does it look like day to day? And so these are some of the activities that you might see day to day. And with that, I'll go ahead and say thank you and let Richard say thank you really quick, and then we can hand it over to Ryan for questions.
Thank you all.
All right, well, Brett and Richard, thank you so much for sharing your inside knowledge on the two programs. And as someone who's working in this program in the past, I cannot express how excited I am to see the fruit of the labor that folks have worked on, and you guys are just moving it and carrying it forward. So much appreciated. And wanted to highlight that the last presentation, we talked about some of the projects being multi-generational, and it is what it is. We have here, those are the massive projects and programs that takes a lot of brain powers, a lot of efforts, not only, a single generation, but, I have carried it on from previous folks that were in the program for a while, and we, step by step hand over the baton. So it is something that, folks who are thinking about joining LA San City, you will be picking up where Brett and Rich are probably leave off of working with them and take to the next level. And the challenges continue to grow because population continue to grow with the population and challenges. So with that, I'm going to transition into the last two slides related to the hiring. So I'm going to share my screen really quick. Okay, again, thanks to Brett and Richard for the very exciting presentation. So with that, I wanted to also talk about the career opportunities at the LA Sanitation. So the first thing that we're really focusing on is the Environmental Engineering Associate, and we're pretty compatible. Our annual starting salary is around $85,000 with annual increases, bonuses over different levels, starting from Associate 1, 2, 3, 4. If you have a PE as Associate 2, you do get a PE bonus, and that's another incentive. And Richard briefly talked about the tuition fee reimbursement program. That's a really good program to advantage of that. So we have a really exciting. We're hiring a lot today and tomorrow, and in the next round of hiring. So I'll go over the events and the recruitment programs that are coming up. But in order for you to be eligible, these are the minimum requirements. You do have to have bachelor's or master's degrees. The minimum is a bachelor's degree. EIT is a plus. As a part of the condition of employment with the city, you do need to get the EIT within the first 2.5 to 3 years of your employment. So if you do not have EIT, it's hard to continue within the city. So that's why we say it's strongly recommended. If you come in with a professional engineering degree or a license, rather, PE, it's a big plus. You can skip a lot of steps and you get a lot of bonuses. Other requirements, you must be at least 18 years old, have approved identity and right to work in the US. It's a hybrid position. I want to emphasize that, we do offer hybrid telecommuting, but you do have to come into the field office.
We might have lost Ryan there.
Yeah, I think Ryan, you're frozen.
So for more information, you can read, you can go to lacityscenter.org/PGL to find more information. Another category that we're hiring right now is a student engineer. You don't have to have a degree. You must be a full-time student. It is not an internship. It is a full-time student, such as Lisa. She is a full-time student, but working as a student engineer. Basically, you're working with the professionals and other associates up to 950 hours a week. That equates to about 20 hours a week. So that's about half time. We have flexible schedule. We work around your exams and midterms and all that. So you can, work many hours when you have time, when you're on break, and take time off when you have to prepare for your exam. And the salary hourly rates are between $20.77 to $32.25, depending on your standing. If you're a senior, you come in at a higher grade. It is also a hybrid position, and you must be able to commute to City of LA locations. So again, more information at the bottom of the presentation. These are the upcoming recruitment programs. So we believe we're going to Society of Women Engineer Regional in Seattle, NSBE Regional in LA, I think at the end of this month. Bay Area, it's tentative. Other on-campus interviews, we are having Public Works Career Fair on the 1st of December at LA Trade Technical College. So it's just local college. All you have to do is show up early and bring your resume. We'll be conducting interviews as well. UCLA Fall Engineering and Tech Fair is coming up. Cal State LA Internship and Career Expo. UC Riverside Society of Hispanic Professional Engineer event is happening as well. And for more information, you can check in with the Career Center at your college or university and get more information. You can download application from online, go to your own campus, and use your school handshake system, show up at our conferences. And we recently had an engineering day last month, and we had a lot of participants. We collected a lot of applications, and we're currently interviewing the applicants. So things kind of happen really quick these days with the hiring process. And these are the 4 programs that you will be placed into once you get selected. So, clean water program. Myself is in the clean water program in the wastewater engineering services. We also have stormwater program where Richard and Brett are placed in. We also have a really big solid resources program. We provide recycling and waste pickup for 4 million people and businesses throughout the city. We also have a supporting division such as executive, customer care, financial management, and regulatory affairs. So there's there's a lot of different variety of interests that you can kind of get into over your career. These are the two of our wonderful folks that are the face of the recruitment program, Project Green Leadership. So you will be or maybe interacting with Deandra and Ani. They are very helpful, and they will follow up rather quickly with any information, any questions that you may have. Again, today is November 1st, the 4th of our Tech Talk series. So with that, I'm going to keep it right there and stop the share and see if we have any questions. Since it's been a while for me, the stormwater program, I have a lot of questions for Brett and Richard. So, we can answer those questions too. If I have time, I will throw them in there. And just so, for the participants, you can type in your questions in the Q&A box. We will call them out as in the order that we receive. Let me see. So the first question that I get is from Angel Gomez to Richard. Have you noticed any trends in your pollution assessment work? This is Angel Gomez from California, Pomona. So any trends in your pollution assessment? What's trending up?
Yeah. So over the last 20 years, we've been monitoring one of the big pollutants that affects a lot of the city's watersheds in the region is bacteria, E. coli, total coliform, and enterococcus. These are indicator bacteria that indicate maybe some sort of other pollution may be present in the watershed. So it's a really good constituent for us to monitor. And over there has been it's kind of been up and down depending on the season, depending on the amount of rainfall. But a lot of our efforts are working to address those bacteria challenges. We also monitor metals as another very poignant pollutant. And for instance, I know that California recently passed a copper brake pad law. And because of the regulations that require less copper in brake pads, there has been a decrease of copper in our watersheds. And that's off the top of my head, those are the trends that I'm thinking of. I don't know, Brett, Ryan, do you have any more?
Yeah, so I wanted to add to that. We have pesticides. Some of them are legacies such as DDT and PCB, PHS. We stopped using them, producing them, but they are in the environment. They do not degrade or they have really long half-life. So, and what we continue to see is basically consumer-based pesticides that we're trying to catch up with. Those are really hard to find solutions for because they have the really short half-life, and when they impact the aquatic environment, it's pretty immediate, and after that they just disappear. So those are one of the things that we're starting to see in the stormwater part. In the wastewater part, of course, pharmaceuticals, a lot of other things, and microplastics, in the stormwater is another issue that we're trying to see, and we're trying to figure out how to deal with the challenge. One question from Doug Walters: is PFAS an issue that you're looking at? So, I can take that question because I'm in the wastewater industry and helping the treatment plant. So, PFAS is it's quite a challenging issue because it's pretty much ubiquitous, pretty much everywhere, and they end up at the wastewater treatment plants. And it's one of the things that regulations are coming up, but we don't really have quite a solution. So we are trying to find ways to deal with that. One of the ways is to do the full advanced treatment. So we have to use microfiltration, reverse osmosis, and advanced oxidation process to fully not eliminate, but bring the PFAS to the level below certain threshold. And the level that we're talking about is parts per billion. So if you have an Olympic-sized water tank, you may have one drop of that, and that is the level of scale that we're looking at. So it's really hard to detect, it's really hard to remove, but we have to do it. And the next question, let's see, I have is from Matthew. Says, how do you consider a plan for climate change in each of your roles and divisions? This is from Matthew from UT Austin. So I'll hand it over to Brett and Richard. I
can take a first shot at responding, and then I'm sure Richard and Ryan have stuff to add. That is a really crucial part for the city. Just two things come to mind really quick. The first is as California continues to experience more and more intense droughts, there has been more emphasis on making sure that we're capturing as much water supply as possible. Maybe in previous years, water quality would really be a dominating focus, but instead of doing treat and release systems or systems where the water is just allowed to evaporate in some way, where now these days we're trying to divert more into the sewer as much as possible so that gets into our reclamation system, or allowing the water to infiltrate into the ground and giving it the time to be captured by the soils and the groundwater supplies, because we just need as much water as possible in the basin. The second response to that would be many of our different projects are designed for a certain size of storm. So the way that we measure those are, we refer to them as the 85th percentile or different percentile storms. And basically it's if you take a history of all the different storms and line them up in order of size, you want to be able to manage up to the 85th largest storm. So that's a designing factor in many of our projects. And we've had to start thinking critically about how does that storm size change and how do we design our BMPs in a smart way? Because what's projected for California and Southern California is that we're supposed to get fewer and fewer rain and storm events, but the ones we do get are going to get bigger and bigger and more intense. And that's just hard to design a system. You don't want a massive tank that's sitting empty for every day of the year except for one. But you also don't want your systems to be undersized because it's not designed appropriately to handle the storms of the future. So that would be a response that came straight to my head.
I just had briefly wanted to add also, when we build projects, we want to, like I mentioned in my talk, we want to think green. And if any of you have heard of the urban heat island effect, that could happen when you have really dense populated areas with little green space that reduces envirotranspiration and overall can lower the temperature of that area. So a lot of our projects, we want to incorporate more greenery, more grass, more plants and such things to address, potential heating up of the environment in a dense city.
Thanks, Richard and Brett. So yeah, there's no one single solution. We'll have to do our parts. Greening is one solution. Removing permeable surfaces from our homes and paved area is another one, to let the water percolate into the ground, as it's always been, until we came to live in the take up the space. And then change our behaviors, catch as much as we can when it rains, put it in our backyard. That's what it, rainwater and stormwater, again with the solid resources, recycle, compost, take that bag of trash away from the landfills. That's one other thing to do. Conserve water. I think we as a city has done a great job by reducing the personal consumption of water over the last couple of years. So we met the challenge, but we have to continue to be self-reliant and be self-sustainable. So, those are a lot of things, as a government employee, civil servants, we're here to find solutions, but we all have to work together as a member of the community, regardless of age and participation. We live in this little isolated planet. So it's all up to us to make the effort. And as the Environmental Engineering Association, your role is going to be intensified, and you're going to be going above and beyond what typical people have to do. So, and then, I want to thank Brett and Richard and Lisa for taking up the role as a future leader of our sanitation. And I know we have a few minutes left, so if there's any other questions, we can maybe take 2 or 3 more. If not, I have a couple of questions. So I do not see any other questions. I'll throw in there. You guys talk about a lot about the projects and managing, different projects and putting pieces together. So, both of you guys have engineering background, and I assume, from my experience in the school setting, those are another skill you probably get exposed to in college, right? So you're focused on, technical part of it. How was it a steep learning curve for you to kind of like get into the, public administration and program management? How was your experience? So I'll start with Richard and maybe get into Brett.
Yeah, sure. So comparing current work, working in the city or any government agency to college, there's quite a few differences. One thing I noticed when I was in school was that I would be given clear projects to work on with clear, well-defined answers. So one of the hardest things for me was realizing there is no clear defined answer. That's our job, is to come up with the solutions. And we have a team of committee usually, or a team of interagency people that can help review and provide suggestions, input. So it's really a collaborative effort until we arrive at an answer that everyone is satisfied with.
Absolutely, totally second all that. And I would, yeah, it was quite a transition where on many of these projects, many of our staff isn't the one drawn on a piece of paper with the design is 90% now. A lot of that is in collaboration with Bureau of Engineering or consultants. So what we do is we're the ones that are shepherding the project. So we're keeping an eye on the costs, the schedule, the environmental permitting, making sure the design team is incorporating comments from other agencies and the public, making sure all the funding is in the correct accounts and ready to go, and any kind of other incidental efforts. So it really is, it's great to have the technical expertise and background, but also really it's important to develop your communication skills, your ability to think on your feet. And I would just highlight how important it is to be able to understand a technical concept and then succinctly and clearly communicate that to different groups, because talking to the Bureau of Engineering is a totally different language from talking with the public or an executive in even our own bureau. So continue to develop those as you go through schooling, and that'll help you be prepared.
Thanks, Brett and Richard. So the time has come. It's 1 o'clock. Again, thank you all for attending this Tech Talk. The next one is going to be on November 8th, and we'll be talking about the carbon emission and counting carbons in our effort to clean the air in the LA. So we're going to switch topic, get into the clean air topic. So I look forward to seeing you again. And thank you again for your time. Thanks to Brett and Richard for your time, and see you again next week.
Thank you, everyone.
Thank you all. Have a good rest of your day.